So, in previous class, we discussed introduction chapter of the course data mining. So, we discussed what is data mining and what are the other terms that describe the data mining, and at the highest level of abstraction, how data mining can be defined as a single process. Okay. So these terms, knowledge discovery from data, extraction of knowledge from data, extracting hidden knowledge from data, they refer to the same thing. So data mining basically is not a single step. It includes several other steps or sub-processes. So these are few sub-processes by which we discussed data mining, and it was a brief explanation of each step. We were discussing different data sources from where we can have data and variety of data on which mining could be performed. So three kind of sources are possible: databases, data warehouse, or information repository. And we were here, I remember. So for mining, most of the common form of data are database, data warehouse, and transactional data. Database, all of us are already aware. Relational database based on the relational model, and variety of different databases on which mining could be applied: stream data or data stream, ordered sequence data, graph data, spatial data, text data, multimedia data, web data, etc. And the data warehouse, in detail, we will discuss in separate chapter. And at this point of time, we can assume it is also a form of representing data. So multi-dimensional data model is used here, and it is basically used by higher level management people in an enterprise or company. Okay. So by providing multi-dimensional views and pre-computation of summarized data, data warehouse systems can provide inherent support for online analytical processing. And we can also apply data mining tools on these data warehouse data. So data warehouse tools support for data analysis. However, for in-depth analysis, if we want to further apply the data mining tools, it is possible. So further to have more detailed or in-depth analysis, data mining tools can further be applied on multi-dimensional data or data space. So it is called multi-dimensional data mining. This process we call multi-dimensional data mining. After that, another form of data that is very frequently used for mining purpose: transactional data. So transactional data means transaction. All of you already aware in your BTech classes. So a transaction should satisfy asset properties. Okay. So asset property, either transaction should be completed or not completed. Partial execution of transaction is not allowed. Okay. Consistency of data by the transaction should be maintained in the database. So Suppose if we take an example of online purchasing on e-commerce site like Amazon or Flipkart, etc. So many customers are purchasing many items and data are generated. So if we take one example, suppose one customer purchased four items. Okay, so in the invoice or payment sheet or payment receipt, there will be entry of four data items, their quantity and amount and total amount like that. But if we are interested mining, we want to apply mining techniques. So what is relevant for us? We might be interested to know which items are purchased by most of the customers like that. So what happens here? We may be interested only data items which are purchased by the customer. So I can have for one customer one transaction in this form, transaction number and the items purchased by the customer. So by processing customer data, it is possible to generate such kind of transaction data. So here it is shown transaction data in form of record. So one value is transaction ID for identifying the transaction, and in second row the items are shown by separating using comma. Similarly, second transaction is shown. Okay, so logically it appears that it is a good representation, but we have to prepare database of this, and we have to apply the mining technique. So how this kind of representation will be appropriate for mining purpose or not? So what happens here? We have database technology and relational data model or relational database is very widely used. So either we should have this representation is possible in the relational database. If it is not possible, then we need to think how this can be converted into the relational database. Relational database, each data is supposed to be atomic. So multi-value data are not allowed. So we have one model that is called nested data model, by which we have other kind of complex representation, multi-valued, etc. So what we need to do, we need to convert nested data model into relational data model. Okay. So either we should convert nested relation into standard relation. Second, one more possibility, we can keep data in flat file. And in flat file representation, it is a simple representation. We keep data in a sequentially in a file. So now machine reads the file. Now for machine, it needs to know where one complete transaction or where the next transaction will start and where the first transaction is completed. So some kind of separator be used. Okay, so some kind of comma, semicolon, or any other special symbol can be used to separate the record. So that is also a very convenient way of uh, storing or keeping transaction data in flat file. So because most of the RDBMS do not support nested relational data, nested relational structure or model, Therefore, transactional database is either stored in flat file or we unfold nested relation into standard relation. Okay. Now, other kinds of data can be of different types depending on the application. So, time-related data or sequence data. Historical data belongs to this category. Stock exchange data, biological sequence data. Okay, so some kind of sequence or time information is associated. Data stream. Today we have online TV and we have stream data services, Netflix and some other service. Amazon also offers. So streaming data, continuous stream of data. And in examples of video surveillance system, a continuous data stream is coming and system is also using it for analysis purpose. So that type of data we call stream data. Sensor data, that means continuous stream of data is coming. Then spatial data, satellite captures map of geographical locations of the earth. Okay, so that map we call spatial data, or data which are related to spatial coordinate or geographical locations, they are called spatial data. So map data belongs to spatial data. Engineering data, engineering design data. Suppose I want to keep details of entire building. Okay, and I want to keep details of integrated circuit chip or any even I can store the details of a component of the machine. So for this kind of data, we call engineering data. So these data are supposed to be very complex data structure. Okay. Then multimedia data, it includes text, images, video, audio. Okay, more than one medium. And then graph data. So social network, information network, we can represent using graph. So how graph data are stored, they are processed, how information is retrieved from graph database, etc. Okay. These applications belong to new challenges. Now all these new applications or new kind of data, we can say, they have few new challenges. Challenges means new problems, and we have to develop solution for those, or we have to develop the technology for those. Okay. So many technology already developed. So here it is written how to handle data carrying a special structure like sequence tree, graph, network. So when we say the problem or challenge, so entire problem we can divide into two steps. How to represent data, and once representation model is developed, then how to store data, a storage model. After that, how to retrieve data. Okay, so some language or some mechanism to be developed. So all these have to be developed for these new kind of data or these new kinds of applications. So how to deal specific semantics? For example, data has ordering, image, audio, video, contents, connectivity. So these are the features of data or semantic of data. So how to deal these data? And then how to mine patterns that carry rich structure. Meaning is when we mine data, we have a large number of patterns, and many patterns are meaningless. And the efforts done in mining process appears to be wastage. So if we develop a mechanism such that only the relevant structure or pattern we get as a result. So it is another big problem. So how to mine patterns that carry rich semantic or structure. Now, when data is mined, so what are the possible formats or way by which data is being represented, or we can say what kind of patterns it can generate. Pattern means arrangement. Okay. Just like when you appear in any joint entrance exam like JEE or GATE exam, and then you apply for admission. Okay, online admission, seat allocation is taking place. Few students selecting that branch or those other institute. So depending on somebody is preferring the institute, somebody is preferring the branch, so other things. Now, online, we can observe how the people are choosing or students are choosing their seat of interest or institute of interest. So the way they are choosing, if we analyze this process, so it will give some kind of help to the student who are waiting. So this is called pattern, how seats are being filled, how students are choosing institute live. Similarly, other example you can also. So there are several different functionalities that generate different kinds of pattern. So when we apply it, generates several different kinds of patterns. So different mining functionality, we have several mining techniques, and each mining technique developed for the for generating a specific kind of pattern. Okay. So few names are written here. Different mining functionalities or activities, characterization and discrimination, mining frequent patterns, association, correlation, classification and regression, cluster analysis, outlier analysis. And in data mining whole course, you will find these as one chapter, two chapter. So each one terminology dedicated to one or more than one chapter in book. Okay. So when we say characterization, so characterization means simply we are trying to describe what are the characteristics, what are the features. So such kind of description is called characterization. And other is the discrimination. Meaning is we also observe things, how they are differentiating, how they differ. So when we try to compare something, then there should be some reference parameter or reference value or reference some object or thing by which we compare it. So discrimination is also a kind of explanation. Description or characterization is also a kind of explanation. Only difference is that in one we only try to describe whatever existing, the features by which that description could be possible. In other form, we describe keeping in view a reference comparative pattern. Okay, a reference as a comparison pattern or comparative statement whatsoever. We will discuss in next slide, next part of the notes. Then mining frequent pattern, that means we have to identify those patterns which are occurring very frequently. Similarly, two or more objects or two objects, they are related to each other. So what kind of relationship they have, association and correlation. Okay, so all these refers to the relationship and occurring very frequently. So next is classification and regression. Classification you understand BTech level, but I asked in previous year student, they told not too much depth they used to cover. Okay, so here we will try to cover in detail. Next is classification and regression. We have some knowledge by which the classes have been defined, and we identify an unknown object and try to make interpretation or try to make decision to which class it will belong. And if we do not have any such knowledge in advance, then the process we called cluster or clustering. So we will see cluster analysis, similarly outlier analysis, classification, regression. So all these are main part of the data mining subject. Classification, association, clustering, outlier analysis. Okay. Data mining tasks can be classified into two categories. I discussed in just above, descriptive and predictive. Descriptive means we want to describe. Okay. Some situation we describe. And predictive, as the name indicates, we want to make some kind of prediction. So this is another way to define data mining task. You know, something we can define from this perspective, from another perspective, third perspective. So this is one perspective. Data mining task can be defined as descriptive mining and predictive mining. So in descriptive mining, what we have, in descriptive mining tasks, characterize properties of data in a target dataset. Simply descriptive or description of the characteristic or properties. Okay. Predictive task or predictive mining tasks perform induction on current data in order to make predictions. We analyze the current data, and based on that we make a hypothesis, and we make prediction. Okay, just like suppose we analyze election data, previous year or previous years, and based on analysis we make prediction that in 2024 who will be the prime minister or which party will come in power. So that kind of prediction we call predictive mining. Now we discuss few more terminology: class, concept, description, characterization, and discrimination. Suppose I have in my shop, I have sale of computer, printer. Okay, so now it will be more convenient to me if I divide all the items of my shop into two categories, computer and printer. Okay, similarly, other item that is also sold by me. So other category can be pen drive. So this is just categorization of the item. So it can be a class name, it can be a concept name also. Okay. So describe represents sales item like computer, printer into. So instead of saying sales item, it is better to say computer and printer, two classes. Similarly, when we have some other kind of data dealing economics of the country, so we have big spender and budget spender, describing customer purchasing power using these concepts. Few customers that have very limited budget and based on their own budget, they have their purchasing habit. And similarly, few customers have a lot of money and they have different kind of habit. So I have two options. Either I should consider customers, one class. Second possibility, big spender and budget spender, two category. Okay. So depending on the availability, depending on the objective, we identify such description or class or concept. Okay. So such description here, data items and activities or concepts of class or concept are called class concept descriptions. Okay. So we can drive such description using data characterization and data discrimination. Things are related to each other. Okay. So class description, similarly here data description, data characterization, data discrimination. So clarity of the terminology should be clear and one term should not be confused with the other. And if two or more terms have the same meaning, it should also be clear to you. So we have three kinds of here descriptions. We can derive such description using number one, data characterization, data discrimination, both characterization and discrimination. Now, something is written about data characterization. So, in most of the cases, what happens here? Summarizing data under study or target class data in a general term. For example, if I analyze data of this MTech first year student, what I have names of the student and roll numbers of the student. So I have two options. I make each individual student identifiable by this and that. And second possibility, I have one class of student class. It has attribute whatsoever. So all the student can be identified by using one set name, class name student. But here all are similar type. Okay. So some kind of, you can say it is a generalization. So instead of using a specific name, roll number, I am using general term. So in most of the cases, you will find this feature is available. Summarizing data under study in general terms. And here, summarizing general features or characteristics of a target class data. The output of data characterization can be presented in different forms. Pie chart, bar chart, they are different representation. Okay, so those charts also have some kind of description. So it is a representation. It is also a knowledge representation of the knowledge. Okay, so resulting descriptions can also be presented as generalized relations or rules called characteristic rules. If it is possible to represent the same thing by some rule, either in form of language or in form of mathematics, whatsoever, so that can also be possible. And we call such rules as characteristic rules. So other definition is data discrimination. As I told, discrimination means how something is differing from the other. So it compares target data class with one or a set of comparative classes, often called contrasting class. Okay. Black color and white color, dark and light color, they are contrast classes or contrast colors. So something we compare with some reference value or reference class. So the output presentation of the discrimination descriptions are similar to those as used for characteristic description. Okay, the way of describing will be the same as we do in description. Only difference is that here we are comparing with a contrast or with a reference class. So discrimination description should include comparative measures that will help in identifying difference between target and contrasting classes. Discrimination descriptions can also be expressed in form of rules, and we call such rules as discriminant rules. Okay. After that, we have discussion on frequent pattern mining, or what are frequent patterns, associations, and correlation. So it is time 10:30. Next class you have from 10:40. So should we continue?
Yes.
So next class is from 10:35.
10:30. So I think because this next discussion will take more time, so 5 minutes will not be sufficient. So I think in next class we should discuss frequent patterns, etc. So I should stop now.